you. Welcome to Eduinfinite grade 11 maths class. And this is the first class with you. So before starting the class, let me tell you a few things which you have to keep in your mind. That is to learn mathematics basically. Just think about A, B, C, D, E. A, attention. You have to give little more attention to this particular subject. And most of the topics of class 11 and 12, I know that you have done up to class 10, now you have reached 11. Now you understand there is a big gap between these two. So this time, like in class 9 and 10, at the last moment, one can manage. But in 11, it's almost impossible, 11 and 12. And most of the times I tell the students that these 2 years, 11 and 12, there are two options. First option, enjoy these 2 years and suffer the rest of your life. And the second option, suffer these 2 years and enjoy the rest of your life. Choice is yours, obviously, it has to be. I mean, you have to work more, you know. And maths, it is a regular practice. It's not that every day you have to practice. I mean, not that say once a week or twice a week or thrice a week, or this month I'll do maths, next month I'll do physics or accountancy, or whatever like. No, so that is most important. Practice, I cannot do alone. We will be doing together. And you have to just tell me one thing, that if you cannot understand my explanation, is most of the time, in 90% cases, I personally feel that it is our fault, it is teacher's fault that the students cannot understand. So if that is the thing, give me the second chance, third chance, fourth chance, so that I can explain in a different way to reach you. Okay? So that is your duty. As long as you are not understanding something, just tell me, sir, what you have said, I could not understand. But at the same time, you have to be attentive. That is A. B, binary. Your approach should be absolutely binary. Either you can understand or you won't be able to understand. In between, there is no such thing. In between, there is no such thing. Okay? There is no grade between understanding and not understanding. So you decide that whether your concept is 100% clear or not. In that case, if it is not, raise your hand and tell me this is the situation. Third, definitely concept. Now, this is the era of MCQ also. Different, maybe a science student, a commerce student, whatever it may be, but all the competitive exams, all the other exams, that is based on MCQ, and MCQ, the concept is very, very important. If your concept is very clear, you'll be able to understand the thing, answer the thing much more easily. And this is the only subject I'm telling you where time management is very important. That those things I will discuss it afterwards. Okay? A, B, C, now D, dedication. Have some passion and love for the subject. If you love the subject will not betray you, I'm telling you. Spend some time, love it. And is most important, exercise. Exercise and exercise. Practice, practice, and practice. That too also, every day. And don't say that today I was attending the maths classes, so I am not doing anything. No. Please keep some time, minimum 1 hour, 30 minutes. Okay? And that will help you a lot. So that is the situation. And again, I'm telling you, if in building up the concept you cannot understand, please raise your hand. Now, we are starting with trigonometry. Now, you may say, why trigonometry? Because trigonometry is the subject where you'll find initially, I found that most of the students find the difficulty in that. So if the difficulty is you can start a little early. So rest of the year we'll get enough time to practice it. That's why. So I'm not started with any mechanical topic. We have started with trigonometry. In fact, we started trigonometry in class 9. So first we'll do something which is supposed to be in class 9, but in some of the curriculum it was not there. So we'll start from the scratch level, from the 0 level. So all of you know that trigonometry, it is coming from the 2 words, trigos and metron. Trigos means 3-sided figure, that is basically triangle, and metron means measure of 3-sided figures, measure of triangles. Now you know very much that it is not restricted within the triangles. It is rather in trigonometry, we include the different things, polygons, circles, etc., any geometrical figure. So, as I told you that we will start right from the scratch. First, we will start with angle. You better write down. I am dictating it a little slowly. We will first write down what I am telling to you. In fact, what I am going to tell you, there are different types of angles. At present, we will deal 2 types of angles. One is geometrical angle, one is trigonometrical angle. So write, your heading is angle in geometry. Angle in geometry. Angle in geometry. Again, I am telling you, if you cannot understand anything, any particular word, just ask me, raise your hand with Zoom option. You just write, if 2 straight lines, oblique rays, if 2 straight lines, oblique rays, intersect at a point, comma, an angle is said to be formed. An angle is said to be formed. So, if 2 straight lines, oblique rays, intersect at a point, an angle is said to be formed. Then you write the second definition for angle in trigonometry. Angle in trigonometry. Okay? You write, if a ray rotates about a point, comma, an angle is said to be formed. An angle is said to be formed. If the rotation takes place, next statements, if the rotation takes place in the anti-clockwise direction, we call it to be a positive angle. We call it to be a positive angle. And if it takes place in the clockwise direction, we call it to be negative. we call it to be negative. Okay? Now read it at least twice and we'll try to understand the meaning of these two, maybe the differences of these two. Again, I am repeating it. Angle in geometry, if two straight lines, oblique rays, intersect at a point, comma, an angle is said to be formed. And angle is in trigonometry. If a ray rotates about a point, an angle is said to be formed. And if the rotation takes place in the anti-clockwise direction, we call that angle to be a positive angle. And if the rotation takes place in the clockwise direction, we call that angle to be a negative angle. Now, there are certain things which are not explained in the definition. It is not told in the definition, but you have to find out. Especially, if we look at the definition angle in trigonometry, it's not given how many rotations it can take. It implies that it can take any number of rotations in any direction. In clockwise, it can take any number of rotations. In anti-clockwise, it can take any number of rotations. But in the case of geometrical angle, if two straight lines or rays intersect at a point, an angle is said to be formed. Now let us try to understand it. Angle in geometry. If two rays, it may be like this, 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 or it may be like this also. And depending upon the size of the angle, we know we have learned it in class 6. This is acute angle, right angle, obtuse angle, straight angle, reflex angle. So basically, angle in geometry will vary from 0 degrees to 360 degrees. 0 degrees to 360 degrees. So maximum, in fact, we'll discuss these boundaries, these intervals, when we talk about the slope of a line, that is angle of inclination. Angle of inclination, if you think of the situation that when it is crossing this 180 degrees, the other end of the line is making an acute angle. Or when it is touching the x-axis again, that time the other end is along the x-axis, positive side of x-axis also. So it is starting, it will include 0. That time the angle of inclination theta, tan theta, that is greater or equal to 0 degrees, less than 180 degrees. Once it is crossing, even 180 degrees, the other end is making 0 degrees. When it is crossing, say 210 degrees, it is actually basically 30 degrees is the angle of inclination. So always think of the situation, what are the limits, what are the intervals and all these things. Now if we talk about the angle in trigonometry, angle in trigonometry, if a ray rotates about one, this is the ray, OA. As I told you, it can rotate in any direction. Suppose it is rotating about O. It can take any number of rotations in any direction. Like this. It is rotating 360, 720 plus 30, say almost. So now it is reaching into final question, OA1. Now you may say, but this is 30 degrees. Yes, inclination wise it is 30 degrees, but basically it is 750 degrees. So if we talk about the two angles, 30 degrees and 750 degrees. Inclination wise, they are same, but as a measure, they are not same. Understood my point? Inclination wise, they are same. That ultimate, the angle between the initial position and final position will be same. That is the inclination, and but the measure of the two angles are different. 30 degrees is not same as 750 degrees. This is number one. It could have taken the rotation in the clockwise direction also. In that case, the angle would have been negative. So basically, there are two differences. Number one, in geometrical angle is restricted from 0 degrees to 360 degrees, whereas in trigonometrical angle, it has got no boundaries. In the positive side, in the anti-clockwise direction, it can make any number of rotations, So it can reach to plus infinity degrees to minus infinity. So interval-wise, one is 0 to 360, one is minus infinity to plus infinity. The second, in the case of your geometry, angle in geometry, there is no such positive or negative angle. In a chapter of class 10, you got some smell of that positive or negative angle. But that time we didn't have to discuss about this positive and negative angle. That was height and distance in trigonometry. Angle of depression and angle of elevation. Angle of elevation is positive angle. Angle of depression is negative angle. One is clockwise direction, one is anti-clockwise direction. Okay. So these are the basically two differences. Now this, how to measure an angle. Now in physics we have learned that they have got the different systems to measure length, then mass, then time. But how to measure an angle? There are three systems of measuring an angle. The most common system I'll tell you one by one. One is known as sexagesimal system. Second is centesimal system. Third one is radian or circular measure. Now, sexagesimal system is the most common system which we have used right from the beginning. When we came to know about angle, angle is a system of degrees. That is what is sexagesimal system. Then one right angle is divided into 90 equal parts. Each part is known as 1 degree. And 1 degree is divided into 60 equal parts. 1 part is minute. And 1 minute is divided into 60 equal parts. Each part is 1 second. Clear? In centesimal system, again, the unit is 1 right angle. And this time, cent means is 100. Means 100 equal parts. So 100 grades. Each part is known as 1 grade. 1 grade is divided into 100 equal parts, is known as centesimal minute. Look at the direction. Sexagesimal minute, centesimal minute. And 1 centesimal minute is divided into 100 equal parts, centesimal seconds. Immediately, the relation between the two we can establish 90 degrees is equal to 100 grades because both are representing one right angle. And therefore 1 degree is equal to 10 by 9 grades. And 1 grade is equal to 9 by 10 degrees. Then we'll come to the third one, that is radian and circular measure. Now, first we write the definition. Write it. Definition of radian. We just write it. Radian is an angle. Radian is an angle subtended by an arc of a circle. Radian is an angle subtended at the center of a circle by an arc at the center of the circle, such that the length of the arc is equal to the radius of the circle. Length of the arc is equal to the radius of the circle. I am repeating it once more. Radian is an angle subtended by an arc of a circle at the center, such that the length of the arc is equal to radius of the circle. Okay, now let's see. So let me draw the situation. This is the circle. This is the radius. Length of the arc AB is equal to OA is equal to OB is equal to, that is radius. If that is so, then this is 1 radian, 1 circular measure of radian. Radian is the angle subtended by an arc of a circle at the center, so that the length of the arc is equal to radius of the circle. Now, one thing you can easily, by observation only, in maths we can find out many things. At least guess something. 1 radian is close to some standard angle. Well, not by standard angle, I know that although there are some more standard angles in trigonometry when you complete the part of trigonometry in class 11. But up to you, it is 0, 30, 45, 60, 90 like that. Now, it is close to something. Correct. It is almost 60 degrees. Because if I join AB, I know that chord AB is less than arc AB. Less than arc AB. But still, OA and OB are equal. So if they're almost equal, means AB is almost equal to OA and OB. So it should be almost 60 degrees. But it is not 60 degrees. Is it more than 60 or less than 60? The question is this. You will find either OA or OB, both are greater than AB. So AB is the smallest side of this triangle. Smallest side will have the smallest angle opposite to it. So those two angles are equal and greater than this angle. Yes, it is close to 60 degrees, but not exactly equal to 60 degrees. It is 57 point degrees. Now, I've given you a definition. I've given you a definition. In fact, the definition contains a tail portion. The tail portion was this. You may write it down. It is a constant angle. It is a constant angle. Now we know certain things. We have reached class 11 that we cannot question any definition. There are certain questions. Now, in this, if we include that question, then it is coming like this. Radian is an angle subtended by an arc at the center of the circle, such that the radius of the circle is equal to the length of the arc. Up to this, I don't mind. It was by definition. The last question, which I told you to write at the end, and it is a constant angle. Who told me that it is constant? As I am telling you that it will be a constant angle. You may definitely raise your hand or point. Sir, it may have some connection with the size of the circle also. Correct. So first portion doesn't demand any proof, but the second portion, second statement, it is a constant angle, it demands a proof. Okay, let us try to find out that. Actually, you know one particular subject we are afraid of, or some of us, out of interest, to put maximum time for that particular topic of mathematics, that is geometry. And directly as such, you won't find geometry is there in near future. In near future, in that form, in that crude form, you won't find. But geometry is the subject which enables us to understand that end of the day, mathematics is nothing. It's not about some formula and substitution. It's all about logic. It is all about reasoning. And so that the knowledge of geometry is not only important to study mathematics for every subject, for every day in our regular life. And geometry, there are different types of geometry. One day I will definitely tell you, if we cannot understand the things of geometry, how it evaporates, I mean, we cannot even think of that. We'll discuss that afterwards. But let me tell you one thing, that this geometry is known as Euclidean geometry. This Euclidean geometry, there are many other types of geometry, Riemannian geometry, and so many types of geometry. And it's not that all these theorems which you have learned in class 7, 8, 9, 10, Euclid wrote all those theorems. No. There are many mathematicians which they contributed in this journey, this flow of geometry. Apollonius, many, Newton, everyone contributed. Most of them have contributed. And you know that when Euclid proposed this, it is based on some axioms, proposition, and definitions. And after, when it became popular, then at different points of time, as I told you that many mathematicians, they contributed. So it is all about different axioms. The play fears another axiom. So one of such axiom is important. What we are doing right now, it will help us. That is one of the properties. That is the ratio of the angles. The ratio of the angles subtended by the arcs of a circle at the center is equal to ratio of the length of the arcs. Shall I repeat? ratio of the angles subtended at the center by the arcs of a circle is equal to ratio of the length of the respective arcs. Now let's see how we apply this. As I told you that by definition, this is 1 radian. I draw a right angle, a perpendicular, ABC. Okay, this is my construction. At O, I draw a perpendicular to OA. Now, angle AOB by angle AOC is equal to RKB by RAC. Now, time to time, I'm telling you one thing that if you cannot understand, it's because of me. So, if the situation is such, please let me know, okay? To rectify my fault and try in a different way. Fine. AOB, as I told you about the axiom, ratio of the angle subtended by the arcs, is equal to the ratio of the lengths of the respective arcs. AOB, 1, I write 1, C. C stands for circular measure. Radian. We could have written 1 R also. By AOC, 1 right angle. By definition, AB, you know AB is what? AB is equally linked to the radius of the circle, that is equal to R. AC is 1/4 of the circumference. 1/4 of 2 pi r. Okay? If it is so, then RR cancels. 1 radian is by 1 right angle is equal to 2 by pi. Or 1 radian is equal to 2 by pi right angles. First, we discuss about this, then we cross multiply that 1 right angle or 1 right angle is equal to pi by 2 radian. Pi by 2 into 1, pi by 2 radian. Clear? Fine. Now, from this result, what is our conclusion? Our conclusion is 1 radian is equal to 2 by pi right angles. 2 is a constant quantity. Pi is also a constant quantity. So 2 by pi is also a constant quantity. So whatever may be the size of the circle, whatever may be the value of the R, it is not depending upon the value of R. That is, it is independent of R. So radian is a constant angle. Understood? We are going to prove that radian is a constant angle. And the second part of it, after cross multiplication, we get 1 right angle is equal to pi by 2 radian. 1 right angle is equal to 90 degrees. Or 1 pi radian is equal to 180 degrees. 2 right angles, 180 degrees. So 90 degrees is equal to pi by 2. 45 degrees is equal to pi by 4. 60 degrees is equal to pi by 3 radian. 80 degrees is equal to pi by 10. Pi by 6 is equal to 30 degrees. So, if anything in terms of degrees or grades be given to you, immediately with the help of that table, we can convert it in terms of radian. And in fact, most of the times, now and onwards, say if sine theta is given in the practical problems in future, that theta, if nothing is mentioned, we have to consider that it is given in terms of radian. If it is degrees, it will be given sine theta degrees. It's not like 9, 10 out here. If degree is out in class 9, 10 level, always sine theta we used to think is degrees, something in degrees. And out here, everything. In fact, when we will be starting calculus, that time we'll see that all the basic formula that will be derived for this particular topic. And it reminds me that another thing we have to do little bit, although directly it is not there in the book that much, but quite often you will find the application of that. The name of the chapter is logarithm. We have done logarithm in class 9, but not up to that level. We will definitely do it once more because in class 12 also you'll find the application of that. Okay? So one day definitely we will spend for at least half of the class we will spend for log. Okay, let's come back to this. And one right angle is pi by 2. So what we come with now, if any angle be given in terms of sexagesimal or centesimal, we can convert it in terms of circular or radian measure, and vice versa. That is just to find express in terms of say sexagesimal or centesimal. We can do that. Now I'll prove and mention two very important formulae which you have to apply very carefully. And I hope we can derive it in one line only. Let's see. And it is, in fact, coming directly from that axiom where I mentioned that the angles are proportional to the angles, ratio of the angles is equal to the ratio of the arcs. Okay. Now, in that way, we can prove that is L is equal to R theta. L is equal to, now you may ask me how we are proving, I cannot understand. Okay, fine, in one line we can do. I consider any length L making an angle theta, and this is equal to 1 radian, and the length of this is R. Okay. Now this will be my construction, join OB, so that AB is equal to R. AB is equal to R. Okay. Now L by R, that is, if I consider this is AC by AB, that is equal to L by R is equal to theta by 1 radian. 1 radian. If we multiply, then we get L is equal to R theta. L is equal to R theta. But one thing you have to keep in your mind, this, there is no unit. You may ask me, what is your radian? If I express theta in terms of circular measure, then there will be no such unit. Because that is the ratio. Shall I repeat? I mean, let me tell you the basic difference of the ratio and the fraction. Basic difference of ratio and fraction. First, what is their similarity? Okay, in ratio, in fraction, we said that it is numerator by denominator. Ratio, antecedent, consequent. But most of the times, if you recall the problems which you have done in class 9, 10 level, you are getting x by y is equal to 2 by 3. Therefore, x is to y is equal to 2 is to 3. You used to write that? That is, whenever I used to get x by y is equal to 2 by 3, our immediate conclusion, therefore, x is to y is equal to 2 is to 3. Or from this, I used to write this, therefore, x by y is equal to 2 by 3. That is, most of the times, knowingly or unknowingly, we used to consider as if they are the same thing. But are they same thing? The answer is no. First of all, there are the similarities, both are compulsive. Both are compulsive. One is, I am finding out a part out of the whole, 1/3. If the total is 3, then one part of it. If it is the total journey is 3 kilometers, I have covered 1/3 of it. It is actually 1/3 kilometer I have covered. I mean, if the total journey is 3, I have covered 1 kilometer. So the ratio wise is 1 is to 3, but actually I have covered only 1 kilometer. It is the comparison of the part with respect to the whole, where ratio is the comparison between the parts. Suppose this room, 1/3, the other portion is 2/3. So ratio of the 2 is 1 is to 2. And that is why, when I am expressing one particular part, some units may be there. But when you are comparing the parts, when you are finding out the ratio of the 2, that 2 units which are expressed in the same unit will be cancelled. So ratio doesn't have any unit. Whereas a fraction can be followed by some units. And third is, sometimes 4 by 8 may not be equal to half. I cannot write it as a half. Sometimes. I'm telling you one thing again and again. If you find that the teacher is talking some rubbish, please raise your hand. That I'm saying 4 by 8, it may not be equal to half. Then I have to justify this. Always, please be involved. Let us make it very interactive. Don't wait for let the other raise the point. No, it is your problem, you raise the point. Understood? Now, 4:8 is always 1:2. A:(b), I can multiply, divide by anything, provided by I'm not doing it with 0. But sometimes fraction-wise, 4 by 8, that may not be half. Now let me, you just write down. Very simple question, this is class 7, 8. But still, I believe that sometimes some basic things we should have 100% confidence. You just write the sum of the numerator and denominator, write it down. The sum of the numerator and denominator of a fraction is 12. The sum of numerator and denominator of a fraction is 12. The next point is, If 1 is subtracted from both numerator and denominator, the fraction becomes 3/7. Find the fraction. Now, some of you are thinking, what type of sound you are giving? You are not of that standard, low standard, we know many things. Yes, you know many things. Still, let's see. By this time, I believe some of you have already solved it. Already solved it. Let one part be x, the other part is 12 minus 6. Because sum of them is 12. You could write it at x and x plus y is equal to x in the numerator, y is the denominator, x plus y is equal to 12. That also could be done. So x minus 1 by 12 minus x minus 1 is equal to 3/7. And if we cross multiply and solve, then we will get x is equal to 4, numerator is 4, and the denominator is 8. So the fraction is 4/8. Is it equal to half? Fraction is 4/8. Can we reduce it to half? Answer is no. Whenever you are reducing it to half, my question is half satisfying those two conditions? Is sum of 1 and 2 is 12? If 1 is subtracted from both numerator and denominator, is it equal to 3/7? No. So sometimes we are not in a position to write a particular fraction in the lowest form. So these are the very small things, but still you keep on thinking of these things. Now, the first formula we have write, that is L is equal to R theta. L is equal to R theta. We could write it down without radian because that time theta, radian by theta, both are expressed in terms of radian. Theta by 1 radian, theta radian by 1 radian. So that's why there will be no unit. L is equal to R theta. So when we write L is equal to R theta, where you have to write it down side by side, where L is equal to the length of the arc, R is the radius of the circle, R is the radius of the circle, and theta is the angle subtended by the arc at the center. Theta is the angle subtended by the arc of length L at the center. The remaining part is very important. And it is to be measured in radian. It is to be measured in radian. That is, L and R, L is, you will get some centimeters or anything, kilometers, whatever unit of length. Even R, unit of length. But theta, if it is given in sexagesimal or centesimal system, you have to convert it in terms of radian, then only you can use the formula, otherwise you cannot use the formula. And another, the length of the area of the sector is equal to half R square theta. Here also same thing. You have to express the angle in terms of radian. Now, some of you must be thinking, oof, right from the beginning, theories, and theories. What to do? In the beginning, there will be. But basically, end of the day, what do I get? As formula section, formula part, three systems. We know the three sections. And in circular division, radian measure, we came to know about what is radian. Also came to know that radian is a constant angle. And how to prove that, also you know. So in the similar way, with the similar axiom, we have proved that L is equal to R theta. And you can try with A is equal to half R square theta also. Although the proof is not, at this level, is immaterial. The application is more important. So one should know. That's why you have given you the proof and all these things. You should know from what it's coming actually. And under this, how far you can do on your own, definitely you will be given the support of the Eduinfinite platform, where this the worked out problems, even the theories, the exercises, that support will be given to you. But please keep in your mind, all these things are there. Even we are there to help you. But do whatever book is selected for the textbook, from the textbook, whichever will be the textbook, please do each and every sum along with the worked out examples. Okay, some of the sums will be very similar, but still, you just mentally, you do mind that there are two types of sums. Most of us, which we like, there are two types of sums. One is easy, the second time is difficult. Easy sum, what to do? Difficult sum, how can I do? So, you don't have to do any sum in that way. You follow that logic. No, my point is, from whatever will be your this thing, the prescribed book, from a textbook, please do. And this is the supplementary part. To understand all these things, even the book sums, if you cannot understand, please send it via WhatsApp. Okay? And we'll definitely do that. It's not that. So, but practice each and every problem from your textbook, and you will be given the proper support from the Eduinfinite platform also. Okay, regarding problems, and this is a very, it's not very big exercise, but there will be two exercises rather you have to do before the next class. One is this, based on L is equal to R theta and A is equal to half R square theta. And second is all those problems which you have done before in class 10, but this time it will be a little twisted, it will be a little lengthy also. Okay? And okay, you have to think something more like that. And I knew that in the whole period, if we practice, if it is a one-sided story from my side, maths is subject we should enjoy together. So I brought some sums for you also. These are very chota sums, short sums. But you just copy the sums, we'll solve it, and we'll try to understand how is the logic, so that to make it more interactive. So I will give those sums to you. I'll give you some time, solve it, then one by one, we'll solve it in the class. Okay? Is it visible? Up to 1, 2, 3, 4. 1 to 5. Okay, I'm calling it out also. Sum number 1. If sine 2a plus 2 cos 3b plus 3 sine 4c is equal to 6, find the value of tan a plus b minus 2c. Second sum. Solve for x 1 plus 3 to the power x by 2 is equal to 2 to the power x. Sum number 3. If a is not equal to b is not equal to c, here just add one more thing, and a, b, c are positive quantities. And a, b, c are positive. Verify whether sine theta is equal to a square plus b square plus c square divided by ab plus bc plus ca is a valid statement or not. Sum number 4. If 3 sine theta plus 4 cos theta is equal to 5, find tan theta. Sum number 5. Solve for x number 1. Sine pi x sine pi x is equal to x square minus x plus 5 by 4 and 5 part 2 cos pi x cos pi x is equal to x square minus x plus 5 by 4 cos pi x is equal to x square minus x plus 5 by 4. And finally, question number 6. If cosec A plus cot A into cosec B plus cot B into cosec C plus is equal to cosec A minus cot A into cosec B minus cot B into cosec C minus cot C. Prove that the value of each side is equal to plus minus 1. Prove that the value of each side is equal to plus minus 1. In case if you find that you could not write it properly, please use your Zoom option to clarify the exact question. We'll definitely tell you. First you try, then I'll interfere. And by this time, if you have got any question, any clarification regarding whatever we have taught you, rather I tried to teach you. So if you have got any doubt, please let me know. Shall I start along with you? Anyone wants to clarify anything, please let me know. By using your Zoom option. And regarding solving a problem, the teacher-student relationship is like that. The worst thing, you cannot get the sum. And that's why you are there. So don't feel shy. Even if you get any problem, that also you just tell us that you got it. Otherwise, one by one, we'll start. Yes.
Sir, I have a question.
Right.
Sir, how is the area of this sector of the circle is equal to half r square theta?
I have not proved it right now because I've kept it for you. And all the things, okay, in future you try it now. The next day you will do it. Okay?
Okay. Okay, sir. Okay.
Shall we start together? Okay, let's start. The first question, if sine 2a, one by one we are writing it on the board also. So those who could not write it properly, is it okay? Sine of any angle. What is sine theta? Because we have not done anything which is, still if our background be just class 9, 10, trigonometry, sin theta, we know that it is less than 1. It is less or equal to 1. And after, within the next class, we'll come to know what is your interval in which sin theta lies. Okay? Sin theta is for sine of any angle is less or equal to 1. Cos of any angle less or equal to 1. Any angle. Okay? So this is less or equal to 1. Cos 3b is less or equal to 1. So 2 cos 3b is less or equal to 2. Sin theta, sin 4c less or equal to 1. 3 sin 4c less or equal to 3. So less or equal to 1 plus less or equal to 2 plus less or equal to 3 is less or equal to 6. But fortunately or unfortunately, it is given exactly 6. This sum is actually less or equal to 6, but it is given to be 6. That means each must attain its maximum value. If one of them be less than, the other has to cover it. If it is less than 1, then this plus this has to be more than 5 to get 6, which is not possible. So this situation is only valid only when they attain their maximum value. So sin 2a is 1, sin 90 is 1. So 2a must be 90 degrees, a 45 degrees. Cos 3b is 1, attains the maximum value. So 3b must be 0. 3b must be 0. So b must be 0 degrees. Sin 4c. 4c must be 90 degrees. So 2c must be 45. I took 2c because I am asked to find out tan a plus b minus 2c. 45 plus 0 minus 45. That is tan 0. Answer is 0. If you have got any difficulty in understanding, please let me know.
So can you repeat once?
Sure. Yeah, can you tell the whole thing? Is it?
So
Fine.
after, okay, yes, sir.
Okay, I'm repeating it. You know that the value of sin theta and cos theta. Sin theta is perpendicular by hypotenuse and cos theta is based by hypotenuse. As perpendicular is less than, numerically less than hypotenuse, so it is always less or equal to 1. That is our fraction. In the limiting case, perpendicular is equal to hypotenuse. In that case, it is 1. But in most of the cases, it is less or equal to 1. Same thing for cos. On the other hand, you will find cosec is always greater than equal to 1. The minimum value is 1. And starting from 1, anything. Similarly, sec, but for tan and cot, we cannot get this type of restriction. I mean, if there was tan on cot, I cannot say anything short of that. I mean, it can be anything. So sin theta is less or equal to 1. That is, sine of any angle is less or equal to 1. Cos of any angle is less or equal to 1. Now, so sin 2a less or equal to 1. Second term, cos 3b multiplied by 2. Cos 3b itself is less or equal to 1 into 2 less or equal to 2. Third term, sin 4c, sin theta less or equal to 1 multiplied by 3. So less or equal to 3. So the sum is coming as less or equal to 1 plus less or equal to 2 plus less or equal to 3. So the left hand side is actually something which is less or equal to 6. But fortunately or unfortunately, I find that it is given it is equated with 6. This is possible only when all these three, sin 2a as well as cos 3b as well as sin 4c, they attain their maximum value. Then only it is possible. Otherwise, it is not possible. So I find, because 2 into multiplied by something less or equal to 2, 3 into multiplied by something which is less or equal to 3. Now, so it must attain the maximum value to reach 6. Actually, the sum is coming to less or equal to 1 plus less or equal to 2 plus that is less or equal to 6. So 2a must be 90 degrees. We know that the sine 90 is 1. Cos 0 is 1. So 3b must be 0 degrees. Sin 4c, that is 1. So 4c has to be 90 degrees, from which I get a, b, c. And I have to find out tan of a plus b plus c. I substituted the value and got it. Okay?
Thank you.
Okay. We come to the next question. This is a very good question. 1 plus 3 to the power x by 2 is equal to 2 to the power x. Now, you know that we will definitely discuss the different methods to solve a problem. And if we think about to answer the competitive exams, it may be after for the commerce boys, maybe for the science students, for the commerce students, anything. So it is basically MCQ pattern, and where you're going to do the sum to get the answer. As long as that is concerned, sometimes we don't go for the direct method for solving. But you know that the board exam, say ISC, CBSC, or whatever, out there, you have to do the sum, not just to get the answer. There, to write the sum is also very important. What to write, how to write it. Whether you have to give the reasons and all this, you have to justify it or not. Okay. If it is, say, you have to guess the answer, that work can be done very easily. Say, for instance, these two are equated. If x be any odd integer, right hand side will be an integer. Say 3, 2 cube, 8. 5, 2 to the power 5, 32. But if it is odd, what will happen to the left hand side? X by 2, 3 by 2, 5 by 2, or 1 by 2, or 7 by 2. It will be irrational. The left hand side will be irrational, right hand side is rational. If it is odd, so it is not possible. X cannot be any odd integer, because in that case, one side will be irrational, the other side will be rational, because it will be some third form will be there. It has to be even. If it is even, we should always try with 0 first. If it is 0, 1 plus 3 to the power 0. 3 to the power 0 is 1. 1 plus 1 is 2. Right hand side, 2 to the power 0 is 1. Is 2 equals 1? No. No. So not. Try with x is equal to 2. 1 plus 3 to the power 1 plus 3 to the power 2 by 2. What is that? 1 plus 3 to the power 1. That is 4. And the right hand side, 2 to the power 2. Yes, 4. So x is equal to 2. If you have to guess the answer, you can guess in this way. But if you have to do the sum, just look at the beauty of the sum. Just look at the beauty of the sum. To get the answer or to do the sum, as I told you, these two are absolutely different. 1 by 2 to the power x. Again, I am telling you, in case you cannot understand, my fault. You will give me that chance to explain. Okay? I am dividing both sides by 2 to the power x. If you cannot understand the step, please let me know. I have just divided both sides by 2 to the power of x. And 2 to the power x cannot be 0, so division by 2 to the power x is valid. I cannot divide both sides only when the quantity itself is 0. This is 3 to the power half means root 3. One to the power x is 1. I have taken half to the power x, and that is root 3 by 2 to the power x. Is it okay? Our next step. This is sine 30. Root 3 by 2 may be written as cos 30. Now you could ask me, sir, you could write this as cos 60 also, and this is sine 30, sine 60 also. Yes. Yes. Same thing. Sine 30 to the power x plus cos 30 to the power to 1. But we know sine squared theta plus cos squared theta is 1. Sine squared theta, cos squared theta is equal to 1. Comparing with that, it has to be equal. Okay? And this was possible for us because root over 1 square plus 3 square is equal to 2 square. Root over 1 square plus root 3 by 2, this whole square. When a to the power x plus b to the power x is equal to c to the power x, and when it is, say, a square plus b square is equal to c square, that time x will be always 2. In this way. Can I go to the next sum? If you have no doubt, then I am going to sum number 3. Okay. Okay, we have done. In fact, this portion will come to us. Why 3 is greater than 2? Why 3 is greater than 2 or 2 is greater than 1 or 7 is greater than 2? The simple reason is, as 3 minus 2 is 1 which is greater than 0. That's why 3 is greater than 2. As 7 minus 3 is equal to 4, which is greater than 0, that's why. If it is less than 0, then it would have been less than this. Fine. I look at sum number 3, sine theta a square plus b square plus c square by ab plus bc plus ca. I take their differences. A square plus b square plus c square. That is the numerator minus denominator. I think you have written down that A is not equal to B is not equal to C and A, B, C are positive quantities. I take numerator minus denominator, this quantity. Let's see. I multiplied by half and 2. That is 2a squared plus 2b squared plus 2c squared minus 2ab minus 2bc minus 2ca. Divide and multiply by 2. Nothing else. Half a square plus b square plus b square plus c square plus c square plus a square. Let's see. A square plus a square, 2a square, b square plus b square, 2b square, c square plus c square, 2c square. Just 2a square plus 2b square plus 2c square is written in this form. Rest is as usual. Okay? I am taking this along with this. A square plus b square minus 2ab. What is that? Right. A minus b whole square. B square plus c square with minus 2bc. Yes, b minus c whole square. And rest is c square plus a square minus 2ca. C minus a whole square. In fact, this particular thing, a square plus b square plus c square minus ab minus bc minus ca, can always be written in this form. In future, if you get this type of situation, you can directly write this step to this step. Because in class 9 also, we have done this, but application-wise, as it is not that popular, so we forget to use that, but you can directly use this. Because this is the particular expression which you'll always get. I mean, frequently you will get. A is not equal to B is not equal to C. Now, this information, it will play now. A minus B may be positive or negative, not 0. Negative square is positive, positive square is positive. This is also some positive quantity. This is also some positive quantity. So, then this sum cannot be negative. This sum is individually they are positive. So, their sum is positive, strictly positive. Not even chance to put a equality sign. This minus this is greater than 0. Therefore, a square plus b square plus c square is greater than ab plus bc plus ca. I divide both sides by this quantity, which is supposed to be positive quantity. I mentioned that. And if we divide that, that will be greater than, correct, 1. This by this will be greater than 1, which implies this by this is greater than 1. Is it possible that sin theta is greater than 1? Answer is no. So, the statement is not valid under that condition. That is, A is not equal to B is not equal to C. Is it clear? Write down, and if you have got any doubt, then definitely let me know. Okay. The remaining 3 sums, I'm keeping it for you. Now, you try because, and you also, as I told you, the 2 exercises, initially, those 2 exercises basically textbook can help you, although you can take the support of this platform. And in that platform also all the types are given. So the remaining 3 sums, do it on your own. And now, if you have got any clarification, any question regarding anything which I have tried to explain, but I couldn't which that I couldn't communicate. If there is anything such like that, and as you know that at present it is very difficult to hold the classes because of this internet problem of Umphun situation, as Corona and Umphun both are there. So please stay safe and sound and try to study, try to do as many problems as possible. And the problems which you are not getting, please send us. We are always ready to help you. Okay? So thank you very much. Again, I'm telling you, if there is any question, you may ask me immediately. Otherwise, from my side, good night.